everyone agree that if you look at all the X bar data, that the mean is going to be the same, but the standard deviation should be smaller? Does that make sense? Okay. So that brings us to the next bit of so that's the idea. This idea has a name and a formula, but I want to make sure you understand the idea first and why the idea makes sense. So, when you take a sample size 2 or 3 or whatever, you expect a lower standard deviation, but the mean you still expect to be the same. And this is what we just talked about. So, I now want to introduce some terminology and some notation for these things, so that we can write down these formulas. Okay. So first of all, we now have to talk about the standard deviation of X bar. So what is the notation for that? It's actually really nice. You just write sigma with a little X bar. It's nice because you can just read it off as the standard deviation of X bar. Now further, the first thing we found was the mean of X bar. What do you think the notation for that is? Exactly, mu with a little X bar. Right, okay. Okay. So now what did we find? We found that the mean for X bar is going to be what? The same as the mean for population. So now we can write that down in formal math. The mean for X bar is the same as the mean from the population. You just write mu for X bar equals mu. Now what about the standard deviation of X bar? That's not the same. But there's an amazing, very simple formula. And here it is. So first of all, we know that the mean for X bar is just the same as mu, the mean from the population. And now I'm telling you that the sigma X bar, the standard deviation for X bar, is the same as sigma from the standard deviation of the population divided by the square root of n. That's little n. What is little n? It's the size of the sample. So what's amazing is that it's a really, really simple formula that tells you your standard deviation for X bar. Is that a little hard to see?
Yeah.
Why don't I just do this again? Okay. Mu sub X bar equals mu, and sigma sub X bar equals sigma divided by the square root of n. And that's little n, the size of the sample. Okay. So notice that we just through a discussion we just figured out that the standard deviation for X bar should be smaller, but now we have a formula that tells us exactly what it's going to be. Okay. So just to make sure that you understand how to do the simple calculation, suppose if sigma equals 8, so the standard deviation for your population is 8, and you take a sample of size n equals 16, what standard deviation do you get? Or in other words, what is sigma for X bar? So how do you do that? Eight divided by the square root of 16, and that equals 8 over 4, which equals 2. So there you go. So I'm going to make you do one that's a little harder. You have to use a calculator here. If sigma equals 1.9 and your sample size is 20, find your standard deviation sigma of x bar. That's a really good question. So round to 4 decimal places is the first thing, but second of all, round as little as possible during the calculation. Because what happens when you round early in your calculation? When you keep doing calculations, what happens? Yeah. Every time you do a calculation with a rounded number, it makes the error of that rounding bigger and bigger. Great question. So what's the command for square root in Excel? It's sqrt. So first of all, you could just type in equals sqrt of 20, and that would give you the square root of 20. But I'm going to tell you an even better and shorter way to do this. You can just type in the whole thing all at once. So first, let's write it out. So when you write it out, what is it? 1.9 divided by the square root of 20. So let's just punch that into Excel directly. Equals 1.9 divided by sqrt of 20. And then you hit enter, and it tells you your whole answer.
How do you divide by?
Divided by sqrt in parentheses 20. Right. Division sign slash, yeah. Okay. So also notice that doing it this way means you don't have to worry about rounding at all. Excel does all the work and all the calculation for you. Yes, Maya. Which part? It's in the corner. It's up top. So here in Excel you can see what to type. Of course, if you're using a calculator, just use a calculator. Okay. So what we see here is that when we take a sample, assuming we know information about, again, we're going to assume that we know the mean for the population, and we assume that we know sigma, the standard deviation of the population. So we now know how to find the mean when we take a sample. When we take a sample, we know how to find the standard deviation. The next big question we need to answer is the distribution of x bar normal? That's something that we haven't answered yet. So here's the answer to this question. Now, why do we want to know whether or not the distribution is normal? Well, once we know the distribution is normal, we can do everything that we've been doing, figuring out probabilities and all. So it would be very, very helpful if we knew that it was normal. Okay. So, lots of experimenting. There's theory and trial and error behind this. We're going to skip all that, and we're just going to say this. If we know that the population is normal, then we know that the distribution for x bar is normal. That's the first one. What if the population is not normal? It turns out that if your sample is big enough, the distribution for x bar is normal. How big? In practice, it varies a little bit, but to be on the safe side, we just say 30. So if your sample size is at least 30, then we say the distribution for x bar is normal. Definitely. So, how is this important or useful? Let's now see how this applies to a problem. All right. So first, let's say that for adult salmon length, the average mu equals 42 inches, and population standard deviation sigma is 6 inches. And let's assume that we have a normal distribution. So fine. First, let's find the probability that one salmon is longer than 46 inches. And we're going to work on the second question in a second. Oh, okay. So, what's the probability? So let's do part A first. So first of all, the probability that one salmon is longer than 46 inches, how do we write that down in notation? Someone not named Oshrit. Right. It's a data value, so it's x greater than 46. So now we have to find this. So what do we do? What's the first thing we do? Draw a picture. Okay. So here's the picture. What do we label on the picture? 0 is in the middle for what? For z. And what else? 42 is in the middle for... Right. So and I label this as... This is an x value. Right. So the mean is 42. Now what? What else do I mark off? Yes, we mark off 46 as another x value. Mark that off, and then what? Shade where? Shade where? Higher than 46. So what does that mean? To the right of 46. So what we want to do is we want to find that area. So how do we do that? Yes. So I want to go through all the steps so you can see what's going on. First we're going to find the z-score. So what is the z-score? How do we find the z-score? So remember, we have an x value, we need to find the z-score. So we do data value minus mean over the standard deviation. And what is that here? 46 minus 42 over divided by 6. Exactly. And that works out to 4 over 6. So, yeah, there we go. Okay. So that's, yeah, that's 2/3. I'm just going to write 0.6, points, yeah, 0.67, that's fine. Okay. So now we have filled in the z-score. So now that we know the z-score, what can we do? Find the area. How you want to do that? Excel. So what do we type into Excel? Norm S dist of 0.67. And that gives you 0.7486. So what is 0.7486 and what do I label with that? Right. So first of all, what kind of value is that? That's an area or probability value. And this is which area? This is the area to the left. This is not our answer. This is this area, 0.7486. What do we have to do now? We have to do 1 minus. So 1 minus 0.7486 equals okay, 0.2514. And is that our answer? Yes, no? Yes. Because we're looking for the probability, and probability is the same as an area. Did we find the area we want? Yes. So that's our answer. Next. Now we do part B. And this is where we have to pay close attention because some things are going to change. Part B, the question is, what is the probability that 4 salmon average longer than 46 inches? So first of all, how do we write the question down in notation? Yes. This is going to be a question about X bar. So how do we write this down? We're still looking for probability, so you write P, but now what do we write? The probability that X bar is greater than 46. Does that make sense? Why are we using X bar? 4 is not the population. 4 is the sample size. We're not talking about one data value anymore. We're saying we took a sample and calculated the mean. That's an X bar. Alright. So this is the question. So now what do we have to do in order to answer this question? Draw a picture. So here's the picture. Now, what do we label on the picture? Z, the 0 in the middle, and what else? 42. Now what kind of value is 42? It is not an X value. We are no longer talking about X values. We're talking about X bar values. So, first of all, these are X bar values. Now we need to check something. We need to make sure that we have got the right information. What is the mean for X bar? Is it still 42? Yes, that's what we just figured out. The mean stays the same. Now, what else do we need to write down to help ourselves out? We're going to need the standard deviation of X bar. What's the standard deviation for X bar? Is it 6? No. What is it? Set it up. It's going to be what? Six divided by the square root of 4. Exactly. That's 6 over 2. That's 3. So what does that mean? That means in this part B problem, the standard deviation that we're using is what? Is going to be 3. Okay. So let's finish working on the diagram and then finish out the problem. So what else do I need to mark off on this problem? On the picture? Well, we actually don't mark off standard deviation on the picture. Okay. But we are interested in a value of 46, and now we want to Shade the area to the right. So the picture still kind of looks the same, but as we just saw, some things are going to change. Okay. So what do we need to calculate now? Now we need to find the z-score. So z equals what? 46 minus 42 divided by, yes, divided by 3. Because what is our standard deviation in this problem? It's 3. We just figured that out. So here we get 4 over 3. So we're going to use 1.33. So this z-score is 1.33. So now we need to go in and find the area. So we now know how to find the area equals norm s dist of 1.33. And that gives 0.9082. So what do I label with 0.9082? Area to the left. Is that what we're looking for? No. What do we have to do? 1 minus. So the area equals 1 minus 0.9082, and that's 0.0918. And that is our answer. Okay. So here's the thing I want to point out. Almost everything is the same except the standard deviation changes because we're now dealing with the sample mean. So when we're dealing with sample mean, what happens to our mu? Stays the same. What happens to the standard deviation? It gets smaller by the formula that we have. So let's update / add a new formula to our arsenal. When you're dealing with one value, how do you find your z-score? It's x minus mu over sigma. When you're dealing with a sample, it looks almost the same. It's value minus mean over standard deviation. But with the sample, what's your value? It's x bar. With the sample, what's your mean? Mu for x bar. With the sample, what's your standard deviation? Sigma for x bar. So the thing we have to pay closest attention to is sigma for x bar because that changes. Okay. So why don't you guys work on these two problems? Okay, let's talk about these questions. So, for the first one, what do? What's the first thing we do? Yeah, everything's already written out in notation. Let's just get straight to drawing the picture. Okay, so what do we label on this picture? Okay, 0 goes in the middle for z, and what else gets labeled? 78 is the mean that goes in the middle, and then what else? And we mark off 70. Okay, and then what do I do? Shade to the left of 70, exactly. Okay, now what? Right. So one thing I want to do is make sure that we know what we're working with. What's the mean in this question? it's going to be 78. Now, standard deviation, first of all, what's the notation for standard deviation? Sigma x bar. And what's it going to be?
6 over
It's not 6.
6 divided by
6 divided by
square root of 10.
square root of 10. That's the whole point. Which works out to what? 1.8974. Alright. So remember, that's the whole point. When we take a sample, what happens to the standard deviation? It changes, it gets smaller. That was the whole point of that discussion, is to keep that in mind. Okay. So now once we know that, now what do we do?
Now we can find the z-score.
Okay. So we can find the z-score, and then from the z-score we find the probability. I'm going to remind you that we can be very slick and skip the z-score step. So using Excel, how can we just go directly here? Exactly. Equals norm dist. Now, it wants an x value. What is our quote-unquote x value? 70, because that's our value. Now, what's the mean? 78. Now, what's the standard deviation? Exactly. The standard deviation that we're using in this problem is 1.8974. Cumulative is true. Oh, okay. And you get something quite small. Wait, hold on. I need some more places here. There we go. Okay. So it's 0.00001. It's actually quite small.
But if we do it through Excel, it's just through finding the z-score. Can we do that?
Do you get something close to that? Yes. Okay. So similarly, you could find the z-score. And what's the z-score? How do you find the z-score? Divided by. And that works out to be what? That should be negative 4 point something. Okay? So now we can just do equals norm s dist of negative 4.2163. And that gives this. But if you push it out one more decimal place, so it's 0.00001. Now, normally I like to say do all your probabilities to 4 decimal places, but here I don't like to do that. Why? Because if you just do it to 4 decimal places, what does it look like the answer is? It looks like the answer is 0, but is that really true? No. It's some small tiny fraction. So I like to go out until I can see exactly how close to 0, but not 0. Okay, then check your work.
We did the same thing, the same exact thing.
Okay.
But it just says 1.3417 E-05.
Oh, that's called scientific notation. So I don't like scientific notation. It tends to muddle the picture. Okay. So what does that mean? That just means it's that number and then move the decimal place. It said negative 05. So move the decimal place 5 places, and because it's negative 5 places to the left.
So it is the same answer.
So it's the same answer, just written in scientific notation. Alright. So there's a way to go into options and get it off scientific notation, which I generally recommend. Okay. So quickly in the time we have left, let's do this other problem. So what's the first thing that we do? Yeah, write this down in notation. We're looking for P what? X bar greater than 14. Exactly. First of all, how do we know that this is an X bar?
Because it says 9 cars.
Right. It says 9 cars on average. So that tells you you're dealing with a sample and you're talking about a sample mean. Okay. So next, how do we work this out? Draw the picture. Alright. So what gets labeled on the picture? 0 in the middle for Z, and what else? And then our X bar values, what X bar value goes in the middle? 12.6. And we also mark off 14. And now what? Shade to the right because it's greater than. Okay. So we know what mu is. At a certain point, I'm going to stop writing down mu for X bar because we know it's just the same as mu. But what do we have to figure out? We do have to figure out the standard deviation. So sigma X bar is what? Okay. So this works out to 0.7. Okay. So what's the next thing we should figure out? Z-score. This one, let's go through all the steps. So here, Z equals what? 14 minus 12.6 divided by 0.7, exactly. And that works out to what? 2. So we figured out our z-score is 2, and now what do we do? Now what do we need to find? The area. And I want to work that out using StatDisk now. Okay. So what are we typing into StatDisk? Yeah, the z value is 2. Click evaluate, and StatDisk is nice, it tells you everything. So, yeah, right. So I'm just going to fill in everything. 0.977, I got to make a choice which way we're going to round. Okay, so I'll say it's 9772 and 0.0228. And what's our answer? 0.0228. That's our answer. Maya. Yes. Okay. So, is that straight? Any questions? All right. So we learned one big new idea today. And that idea is, what do you do when you have a sample? All right.